Welcome back, everyone. We'll continue with 7.8, a definition of an improper integral of type 2. In the earlier video, you saw examples of type 1 improper integral. Now we will see how improper integral of type 2 is evaluated. If f is continuous on the interval a closed open b and is discontinuous at the endpoint b, then integral a to b fx dx is defined to be integral a through t limit as t approaching b from the left fx dx, provided the limit exists. If f is continuous on open A close to B and there is a discontinuity at the lower limit, then integral A to B fx dx equal to limit as t approaching A, t approaching A from the right, then integral t through B fx dx. So if the discontinuity of the integrand occurs at the upper limit, then you will allow t to approach the upper limit minus. You will approach the limit, upper value, the upper limit from the left. If there is a discontinuity at the lower limit, you will approach t from the right side of the lower limit, a plus. The improper integral a to b fx dx is convergent, is said to be convergent if the corresponding limit exists and divergent if the limit does not exist. If f has a discontinuity in between the 2 points, in between the interval, a c, where discontinuity occurs at c, and the c occurs between a and b, and both integral a to c fx dx and integral c to b fx dx are convergent, then we write integral a to b fx dx equal to integral a through c fx dx plus integral c through b fx dx. But remember, there is a discontinuity at c. So for the first part, there is a discontinuity at the upper limit. For the second part, there is a discontinuity at the lower limit. So when you do discontinuities, when you have improper integrals having discontinuity at the upper limit or lower limit, then you have to apply the techniques that we explained in part A and part B. That means for the first integral, you have to allow t to approach c from the left. For the second integral, you have to approach c, you have to approach t to the limit c from the right. So here, if you notice, there is a discontinuity as at a. So we are evaluating the integral from t to b. So there is a discontinuity at a in this figure. There is a vertical asymptote. So the integral should be treated as integral t to b, the limit as t approaching a plus from the right side of the lower limit. In this part, there is a discontinuity at the right limit at B. So what do you do? When you do the limit, you have to do limit. Here it will be from A to T, and then T approaches B from the left. So discontinuity occurs at C, where C is between A and B in the third figure. So what we have to do, we have to write the integral as two integrals. This I1 and I2. So in I1, because the discontinuity occurs at the upper limit, you will write T, this will be A to T, T approaches C from the left. And for I2, you would write integral C to B, so it is T to B, the limit as T approaching C from the right. So this is how you do type 2 improper integrals, where there is a discontinuity either at the lower limit or at the upper limit or in between the lower limit and the upper limit. Let's take this example. Find integral 2 to 5, 1 over square root of x minus 2 dx. So find, let's call the given integral as I. So for clearly there is a discontinuity at the number 2, and that occurs at the lower limit, right? So integrand the f of x, which is equal to 1 over square root of x minus 2, is discontinuous at x equal to 2, which is the lower limit for the integral, lower bound of the integral. So what do we do? So 2 is where the vertical asymptote occurs. So we have to write wherever the discontinuity is, call it t, t through 5, and limit as t approaching 2. Now you have to decide whether it approaches from the right or left. If the discontinuity occurs at the lower limit, you will have to use 2 plus. If it occurs at the upper limit, you would use 2 minus or 5 minus. That is 1 over square root of x minus 2 dx. That is, let's keep the limit as is, limit as t approaching 2 from the right. We have to integrate this. In order to integrate, write this one as x minus 2 to the power negative 1 half dx. Now it is limit as t approaching 2 from the right. Then it will be x minus 2 to the power negative 1 half plus 1. So it is positive 1 half over positive 1 half between t and 5. The limit t approaches 2 from the right, the 2 times. Now you're going to have x minus 2 to the power 1 half. So now you're going to apply the upper limit. That is 5 minus 2 to the power 1 half. Now we apply the lower limit, which is t minus 2 to the power 1 half. So t is approaching 2 from the right. So now it is 2 times square root of 3. 5 minus 2 is 3. 3 to the power 1 half square root of 3. Now, this is 2. T is replaced by 2 plus, which means something, a value more than 2. So it is more than 2 minus 2. So that will be equal to 0. This part will become 0, close to 0. So this value is equal to 2 radical 3, which is actually finite. So this improper integral turns out to be a convergent improper integral. Hope this video helps. Welcome back. I would like to show you one more example just to understand the concept of improper integral, why we need to do the limit as t approaching infinity part in these problems is very important to understand. Why we cannot do the problem the way we did earlier, definite integral problems. To clarify that, let's take one example. Evaluate the integral 0 to 3, 1 over x minus 1 dx. So here, if you look at the problem, there is a discontinuity at 1. So f of x, which is equal to 1 over x minus 1, is discontinuous at x equal to 1. X equal to 1 occurs between between the limits of the integral, which is between 0 and 3. So this integral is improper integral type 2. So we need to write this integral as integral 0 to 3, 1 over x minus 1 dx, as integral 0 to 1, 1 over x minus 1 dx, wherever the discontinuity is, then 1 through 3, we have 0 to 3, 0 to 3, and then there is a discontinuity at 1. So you are splitting the integral into two parts, one from 0 to 1, the other one from 1 to 3. 1 over x minus 1 dx. So if I do integral, the first integral, I1, I call it I1 plus I2. If I do I1, this integral 0 to 1, 1 over x minus 1 dx. So there is a discontinuity at the upper limit. So you need to write limit as t, integral 0 through t, 1 over x minus 1 dx. T approaches 1 from the left because the limit, discontinuity occurs at the upper limit. So you have to approach from the left. So now if you integrate this, it's limit as t approaching 1 from the left. Integral of 0 to t 1 over x minus 1 is ln of absolute x minus 1 between the limits 0 and t. So limit as t approaching 1 from the left. You plug in the upper limit and the lower limit. It's ln of t minus 1 minus, with the absolute sign, minus ln of 1, 0 minus 1, absolute sign, so it will be ln of 1, which this part is 0. So here, ln of absolute t minus 1 as t approaching 1 minus. So 1 minus. So it will be slightly smaller than 1. So you are going to write that to be, this will be slightly smaller than 1 and minus 1. So it will be very close to 0, but it is from the right. So what will happen is its integral, so this will be ln of ln of 0. This is going to be ln of 0 plus, so which will be equal to negative infinity. Ln of absolute t minus 1, and t is uh, approaching 1 from the left, so it's slightly smaller than 1, minus 1. So let's say it's 0.99 minus 1, uh, but it's going to be a value very close to 0, so it's 0 plus, but ln of 0 plus is going to be negative infinity. Why? If you look at the ln graph is going to look like this. So when you allow t to approach 0, 0 from the right side, the ln value is equal to negative infinity. So this means that the integral is divergent whether I2 is convergent or divergent. So anyway, we are going to add a negative infinity to either a finite value or an infinite value, doesn't matter, but ultimately the integral is divergent. So the original integral I is divergent. This is the way it is done by improper integral. But if you had done this by regular method, if you had done this problem by not treating as improper, then you would have written this as 0 to 3 1 over x minus 1 dx equal to ln of absolute x minus 1 between the limits 0 and 3. This will end up like ln of 3 minus 1 ln 2 minus ln of 0 minus 1 within the absolute sign ln 1, which is equal to 0. So you would have said that its value is equal to ln 2. And this is incorrect. This means that the integral value turns out to be ln 2 if you had done it non-improper integral way, which is incorrect. So caution. So this cannot be done by the regular methods, by regular indefinite integral method. So this is the right way of doing it. So treating the problem as uh, improper integral of type 2. So remember that recognizing the problem as an improper integral is very important. So if you notice that 0 to 3, 1 over x minus 1 dx, if you had done only calculus 1 techniques, you would have given the answer as ln 2, which is incorrect. I have done some problems from the additional suggested problems in my videos for this section. So please check for more problems, the videos on 7, 8. I think I have done the problem 9, 13, 31, and 21. These problems are done in the next set of videos. Please take a look at them. Watch those videos. Hope these videos help.